This is an introduction section of word embedding lecture from the Advanced Machine Learning course. Sometimes data is collected from a number of individual sensors. Putting these sensors together per measurement or sample as a list, an array, or vector is a natural way to represent this sample. For example, height, weight, skin tone, eye color, hair color, and many more may be measurements about a person. We represent each as a dimension and can walk across the space of all humans represented by those measurements, traveling along each of these dimensions independently. From a collection of samples presented as vectors, we can learn how these dimensions interact. For example, is there correlation between eye color and the height of people? We can also apply transformations, which eventually may enable us to build predictive models on the human space, or we can use existing powerful machine learning models. So we can do reverse too. If we have vector data, we can assign dimensions to parameters of a cartoon face and do it in a way that faces are semantically meaningful to us. Chernoff faces, due to Hermann Chernoff, are a way to semantically represent multivariate data. Imagine an operator controlling a state of a nuclear reactor, a human operator, but instead of observing tens of parameters, she just looks at a cartoon face, and if the face grows unhappy, investigates further into what's going on. Humans process faces in about 100 milliseconds. Wouldn't it be nice to assess the status of a complex process as fast? But what if we want to vectorize words by meaning into some form of a semantic space? So, what does a word mean? Let's ask humans. William Labov in 1973 constructed this experiment when drawing of different objects which are similar yet sometimes different were made in order to try to assess and distinguish the meaning of words cup and ball. What happened? They employed human subjects and asked them to label objects on the right as either a ball or a cup. After getting all of the responses, they constructed, or he constructed a definition based on those responses. So what's interesting is the question, where does the cup category end and the ball category start? Absent of everything, you can see on the picture here that it depends on diameter. The larger the diameter, the more likelihood it's becoming a ball. We're plotting only one parameter here, but there could be other parameters that we can consider independently, or there could be multiple parameters. At least we can look at 3 together. So as you see from this picture, without any other information, without any other context, it's most of those objects were labeled as a cup, likely to be a cup. But let's add context. Let's add context whether there is food in it or not. And then suddenly, depending on the context, this intersection line shifts dramatically. So boundaries between semantic meaning of the same objects for cups and balls shifted. They are context sensitive. So William Labov started thinking about this and this interesting observation, and tried, based on that, give a definition of what is a cup. So the term cup is used to denote round containers with a ratio of depth to width of 1 plus minus r, where r is less than or equal to rb, and r sub b is sum of alpha 1 to alpha v, and alpha 1 is a positive quality when the feature I is present and 0 otherwise. So it's when it's a positive quality, and the features are with one handle, made of opaque vitreous material, used for consumption of food, used for consumption of liquid food, used for consumption of hot liquid food, with a saucer, tapering, circular in cross section. Cup is used variably to denote such containers with ratios width to depth 1 plus minus r, where r sub b is less than or equal to r, which is in turn less than or equal to r sub l, with probability of r sub l minus ratio of r to r sub t minus rb. The quantity 1 plus minus r sub b expresses the distance from the model value of width to height. Nice, right? Cup and bowl. What could be simpler? And we're just trying to create those technical definitions, going deeper and deeper in details. Now the meaning, or at least the feeling for a human of what are we talking about is lost, even though we're trying to precisely define what we already know, or have an idea of what it is. So thinking similar thoughts, Ludwig Wittgenstein, philosopher of language, in his late years a proponent of studying ordinary language. So if in his view, if we misuse words when they have lost their meaning, it could create an inconsistency. For example, a man loses his dog, so he puts in an ad in the paper, and the ad says, "Here, boy." Wittgenstein, in his philosophical investigation, looked at definition or the meaning of the word game. Let's look at what he writes. What is a game? Board games, card games, ball games, Olympic games, and so on. What is common to all them? Don't say there must be something common or they wouldn't be called games, but look and see whether there is anything common to all. Look, for example, at board games. Now pass to card games, pass next to ball games, which much that is common is retained, but much is lost. We can go through the many other groups of games in the same way, can see how similarities crop up and disappear. No better expression to characterize these similarities than family resemblances. But if someone wishes to say there is something common to all these constructions, namely the disjunction of all their common properties, I should reply, now you are only playing with words. Well, how about a radically different approach? The meaning of a word is its use in the language. Ludwig Wittgenstein. So that's what he suggested. Instead of objectively trying to define a word, just look how, well, it's also objective, but it's more observation rather than normative. Just looks how the word is used, and that defines the word's meaning, not some external normative definition how it should be. Observe an interesting phenomenon in linguistics. Most of the dictionaries are normative, like they prescribe the use of the language, but there are dictionaries that are more sort of empirical, observational. They don't prescribe how the words should be used, they then just observe how the words are used and report them. So words, according to this approach, are defined by their environments, by the words around them. So Zelig-Harris in 1954 said, if A and B have almost identical environments, we say that they are synonyms. Here's an example. What does enjoy mean? Suppose you see these sentences. Enjoy is delicious sautéed with garlic. Enjoy is superb over ice. Enjoy lives with salty sauces. And then, before you've seen this, spinach sautéed with garlic over rice. Charred sun leaves are delicious. Collard greens and other salty leaf greens. Conclusion is, ong choi is a leafy green like spinach, chard, or collard greens. Ong choi, water spinach. Our goal in this lecture, or my goal in this lecture, is to show you various methods of embedding words in vector space such that words that are similar in their use in the language or meaning, that's how we define it, or at least that's how Ludwig Wittgenstein defined it, end up together in this vector space.